Sorry for the delay. So thank you for this opportunity to come and talk about the 6G-XR project, which stands for 6G Experimental Research as a full name. Now, the project overview is as follows. We have a EU contribution about 9 million euros and part of Stream C, obviously, and the project coordinator still officially is me, but due to some of other activities, I do not have enough time to allocate for this. So Dr. Jussi Haapala will be taking over soon on being a project coordinator of this particular project. We have in this project 15 partners coming from 8 countries around Europe, and the duration of the project is 36 months. Here can you see the consortium. We have a big number of large companies, starting with Nokia, Ericsson, Telefonica, Interdigital, and Capgemini Engineering in Intel. And then we have a couple of SMEs, Matsuko, Raytrix, and Vicomtech. And then we have few academics, I2CAT, Instituto de Telecomunicações from Porto, from Aveiro, and University of Oulu. And Martel is our Swiss partner taking care of our communication activities and cascading funding activities. And then we have also from Finland VTT. The key objectives, obviously, stemming from the Stream C requirements, is to build a research infrastructure, multi-site of such, that can provide a validation platform for multitude of foreseen 6G use cases. We have 2 use cases that we are going to test within this project, but since most of these platforms within the project have been existing 5, 6, even 7 years, they already have built in a huge number of different kind of capabilities that can be used in a large number of different vertical applications. Validate the multi-access edge computing scenarios. How do we see the softwareization of future network coming in, and how do we see the edge computing and where to place these computing capabilities is one of the future challenges that we need to also take a look at in these experimental platforms. And the innovative 6G applications, I will have a couple of words about these, are holographics and remote control from digital twin platforms. So our methodology and approach is as follows. As I mentioned, we have 4 platforms in the heart of this proposal. We have 2 north nodes, the other one coming from University of Oulu, 5GTN, a research infrastructure, and the other one also from Oulu, VTT 5GTN research infrastructure. On the south side, we have Madrid and Barcelona, so 5G Tonic from Madrid and 5G Barcelona run by I2CAT. We have 4 well-defined technical work packages targeting the future solutions for these 6G use cases. First one is the network and computing enablers, where we look at the next generation softwareization of network with looking at end-to-end slicing, providing multi-stream kind of and synchronized capabilities. How do we do the service migration of future video services, for instance, without the hiccups and so on and so forth, smart orchestration, and what is the 6G control plane, for instance, allowing services such as holographic communications. The second work package is domain is this XR enablers, looking at technologies, algorithms, methodologies, providing volumetric reconstruction. Where do we do the XR processing? Is it now people talk about cloud native, but maybe the next term would be cloud continuum native computing. Low latency, XR delivery, then XR synchronization and interactions, and then fitting these technologies into the platforms. We have DAS 2.5 and 3.6, which then will feed the technologies onto the platforms that we see. On the other hand side, we have the run enablers, where we look at basically three domains of run development. First one is to follow the evolutionary path, where we look at how does the 3GPP run technologies based on standards, how do they develop and keep at least some of the platforms up to date with commercial grade systems, and providing thus a commercial grade platform for testing applications, user devices, testing equipment, so on and so forth. The second path is open source devices and software, looking at open air interface based radios for millimeter wave frequencies, obviously also for lower parts. Those two already exist, but even develop those further, but going for the millimeter waves with the open air interface radios and open core, this kind of open everything approach for the future networks, and also on the RAN side. And then the third part is going beyond millimeter wave to sub-terahertz frequencies, or at least higher millimeter wave frequencies beyond 100 gigahertz, to develop some kind of transceiver pair to see what type of KPIs we can achieve, given that we are now having larger bandwidths in a larger, higher center frequencies. Then we have obviously the use cases. I will have one slide of the use cases later on, but they are, as I mentioned, holographic communications, as well as virtual control, remote control from a virtual world, and then cascading actions. We have one slide about that cascading actions. So the holographic communications system, which is being developed in the southern nodes of the Spanish partners and German and Slovakian partners, is existing in many parts, but there are certain parts that need to be developed within the project, and those are highlighted with some of the dotted red lines, where some of the technologies are being developed within this project. So these are the XR enablers that will then be deployed into the platforms to be able to do the holographic communications in a pilot concept, proof of concept kind of an environment. The second use case is basically virtual remote control in 3D digital twins. Nowadays, I guess, the metaverse. So we have two options which we may try. The other one is that we have at the University of Oulu, we have a Fab Lab, which has a 3D model, so virtualized model, and that will be equipped with extremely capable radios with positioning capabilities also. So we have constantly photorealistic camera view in the environment, then we have virtual view into the environment, and then within this environment, where we have a lot of different kind of tools, for instance 3D printing tools, so we can see all of them in photoreal world, in this virtual world, but within this virtual space we are planning to build virtual design studio or virtual remote control studio, wherein you can then, for instance, go and in this virtual world do the 3D printing design, and then release after you have done it with the avatar professional telling you if there is something wrong. You can adjust your designs there, and then when you are done, you can launch this design from this virtual world into the real-time virtual world, which you can then follow on the real world. So basically looking at how deep the rabbit hole can go when we go into the virtual world.
1 minute, please, Ari.
Yes. Then there is the cascading actions within 6G-XR. So we have received funding of 1.8 million euros with the 60 kilo euro for an action totaling somewhere approximately 30 projects, open call projects. 3 open calls are currently planned, month 9, so September this year, May 24 and March 25. Initially, these are the planned dates. And the topic areas planned for the cascading actions include networking and computing enablers, XR run enablers, energy measurement enablers, 3B enablers, whatever comes from 3B projects, and then for the pilots, if there are some use cases that people want to try out, the vertical replicability enablers. So this in brief. Thank you very much.